Hi, this is the next video for hypothesis testing. So in the last video I explained what a hypothesis test was. For these questions you're going to be doing this hypothesis testing in conjunction with the binomial distribution. I talked about what the hypotheses were. So a hypothesis is just a claim or a statement. And we have two hypotheses. We have the null hypothesis, which we write as H0. And that's going to be, in this case, P equals something, where we believe this to be true. So our null hypothesis is our default statement that we believe to be true. Now in these examples, we're going to be doing one-tailed tests where the alternative hypothesis, H1, is going to be testing, or is going to be where the probability is less than this or greater than. So we're looking to show whether actually the probability is less than what we think it is or greater than what we think it is. So if you see alternative hypotheses with an inequality, then we do a one-tailed test. Now, throughout these questions, I'm going to show you how to structure your solutions. Hypothesis test questions are usually worth about 7 or 8 marks, and there's no part A, B or C, there's just one question, and you are expected to show enough information to get all the marks. So when you are carrying out a test, you need to formulate the test statistic. So this is writing out the information for the binomial. You will get marks for writing down the two hypotheses. You will get marks for doing some calculations. So this is using your binomial CD button on your calculator to work out some calculations with respect to the test statistic. You'll get a mark for comparing it to a significance level, and then you'll get a mark for a conclusion, and if it's in a context, you'll get an extra mark for the conclusion in a context. Okay, so there's a lot to it, and you need to make sure that you cover all of those things in order to pick up the marks. I want to show you what I'm talking about and to give you an idea by considering this little scenario. Okay, so it says, one rainy day, Mrs. Battersby, that's me, Miss Denny, Miss Davis and Mr. Gillibrand were playing a game, and the game was entirely random, so each person had an equally likely chance of winning. So the game, if everyone's got an equally likely chance of winning, the game is deemed to be fair, and because there's 4 of us playing, then the probability of successfully winning would be 0.25. So that's our P, and that's what we are assuming is true, because the game is said to be fair. They play 10 games, and Mrs. Battersby, that's me, won 5. Miss Denny thinks that I've won too many and accuses me of cheating and sets out to prove that she did. So first of all, why does Miss Denny think that I've cheated? Well, we can work out the expected outcome. So the expected outcome is, in this case, the expected number of wins. The notation for the expected outcome is E bracket X. E stands for expected, and the X is the random variable, which is the number of wins in this case. To work it out, we do N, which is the number of trials, times the probability of success. So in this case, the expected number of wins is going to be 10 times 0.25, which is 2.5. So Miss Denny has calculated this and realised that I should have won 2 or 3 games. Obviously, I can't win 2.5 games. So because I've won more than my fair share, Miss Denny thinks that I've cheated. Okay. Now, 5, what you need to be thinking about is 5 wins beyond all realms of possibility? Okay. What are the chances of me winning 5 games? Well, you think it's entirely doable, perhaps. If I'd have won 9 games or all 10 games, then, you'd think the chances of me winning all 10 games would be incredibly small. So the fact that I've won all 10 probably suggests that I've cheated. But 5, maybe, maybe not. So this is what the hypothesis test is. If I've manipulated the game to increase my chances of winning so that I've won more games than I should have done, that's what we need to prove. Now, Miss Denny wants to prove that I've cheated, but how confident does she want to be? Can she ever really be 100% confident? No, I don't think she can. But how confident does she want to be? Does she want to be 95% confident that I've cheated? Does she want to be 99% confident that I've cheated? Does she want to be 90% confident that I've cheated? This is what the significance level is. So it's how confident you want to be in order to prove something. So 95, if you want to be 95% confident, then you are going to test a 5% significance level. So we're looking, if we're doing a 5% significance level, to show the probability of me winning that many games is less than 5%. So that's what we're going to try and do. So let's do some maths. So assuming I'm guilty, then the null hypothesis, H0, is that the probability of winning is a quarter. So we're assuming that the game is fair. Now, because I've won more than a quarter of the games, the alternative hypothesis in this case is that the probability is now greater than a quarter. By cheating, I've increased the chances of me winning. So those are our hypotheses. It's greater than because I've won more than what I should have done. So because it's an inequality, we're looking at a one-tailed test. Okay, so we're going to test this at a 5% level of significance, which means we want to be 95% confident that I've cheated. Here is the binomial distribution information. So we've got the random variable, the number of wins, is distributed binomially with parameters. Number of trials is 10 and the probability of success is 1/4. So we're going to work out our probabilities based on these numbers. Now we can do this in 2 ways. So depending on the question, there are 2 options for how we go about it. We can use what we call the test statistic to compare to the significance level. Now in this case, our test statistic is 5 because I won 5 times. So 5 is our test statistic. And we can work out probabilities associated with this test statistic and compare it to the 5% significance level. The other option, if you don't get a test statistic, then they will ask you to work out a critical region. Now in this case, the critical region will be the smallest number of wins that I would have had to have done in order to conclude that I've cheated. Now it might be 5, that's what we've got to try and show. It might be 6, it might be 7, it might be higher. Okay, so the critical region is in this case, going to be the smallest number of wins that I would have had to have done or got in order to reject the claim that I'm innocent and prove that I'm guilty. Okay, so I'm going to show you both methods. Okay, so method 1 is using the test statistic. So if you're given a specific number of something that's happened out of a number of trials, then you've got a test statistic. Okay, in order to reject the null hypothesis and conclude that I have cheated, we need to show that the probability of winning 5 or more games is less than 0.05. So I'll just explain where these numbers come from. This number here, this is the significance level. So we need to show that the probability is under 5%. So the chances of me winning is small. The 5, that's the test statistic. And we have written greater than or equal to, it's greater than, because that has to match the alternative hypothesis. So because this is greater than, then this has got to be greater than. And then because I got 5, we also put greater than, we also put the equal to. So this is always ever going to be greater than or equal to, or less than or equal to, depending on the alternative hypothesis. This is always going to be less than, and then this will depend on what the chosen significance level is. So in this case, this is the 5%. Okay. In order to reject the null hypothesis, we need to show that the probability of this is less than 0.05. If this is less than 0.05, so if the chances of me winning 5 or more games is less than that, so small, but yet it still happened, then with 95% confidence, Miss Denny can conclude that I've cheated. If this is not less than 5%, then there will not be enough evidence to say that I've cheated. So that's what we're going to try and find. Now we're going to use the binomial CD button function on our calculator. X is going to be the 5, N is going to be the 10, and P is going to be the 0.25. Okay, now don't forget, when you're using this, it gives you the probability that X is less than or equal to your value here. Okay, because we want more than, then I'm going to do 1 minus the probability that X is less than or equal to 4. So we want the probability of 5, 6, 7, 8, 9, and 10, which means we don't want 4, 3, 2, 1, or 0. So if I stick that in my calculator, so X is going to be 4 in this case. X is going to be 4, N is 10, P is 0.25, so we get 0.9219, 1 minus that. So 1 minus that is 0.0781 to 3 sig figs. So the chances of me winning 5 or more games is 0.0781 or 7.81%. Because that is bigger than 0.05, we fail to reject the null hypothesis. So because this is not small enough a probability, then we cannot reject the null hypothesis, and there is not enough evidence to conclude that Mrs. Battersby has cheated. The probability is not small enough, so in other words, I had a better chance. Okay, so all of that will get you marks. Okay, we will get marks for our binomial information. So this is all the things that you'll be expected to write down. You'll get marks for your null and alternate hypothesis. I would always write down some sort of statement which you are working to base things on. You'll get marks for your calculation. You'll get a mark for, so we're looking at 1 for that, probably 2 for that, probably 2 for that, 1 for making a comparison between what you've calculated and the significance level, 1 in this case for saying something about whether either you're going to fail to reject the null hypothesis or whether you're rejecting, and then because it's in a context, you need to put something about it being in a context. Okay, so using the test statistic, by comparing the probability of getting that with the significance level, we have failed to prove that I have cheated. Okay, so 5 wins was not enough to prove that I've cheated. So what we could do now is do the second method and work out what is the number of wins that I would need to have made in order to prove I've cheated. We know 5 isn't enough. Okay, so this is where we now, option 2, is to look for the critical region. So in this case, we need to show for some unknown value. So in this case, R is going to be the minimum number of wins. We need to work out a value of R, so the smallest value of R, that this is true. Okay, now because you cannot get greater than or equal to off your calculator, then this is the same as this. So if you think of the previous slide, we wanted that, so I just did that. So to work out this value here, we need to work out this here. Okay, so this is what we need to try and show. So we're looking for a number that's going to go in here that's going to put this probability below 5? Well, now we know this wasn't 5 and this wasn't 4. So let's say I decide to make r equal to 6. Then I'm going to do 1 minus the probability that x is less than or equal to 5. If I work that out, I'll get 1 minus 0.9803, which is 0.0197 to 366. So you can see when this is 5, when I take it away from 1, then 0.0197 is now below that 5%. Okay, so r minus 1 was 5, therefore r equals 6. So the probability of getting 6 or more wins is 0.0197. Okay, because 0.0197 is less than now my significance level, then I can say that the critical region is x is greater than or equal to 6. Okay, so I've worked out that I would need to have won 6 or more games in order for the probability to be so small, less than 5%, but yeah, it still would have happened that can prove that I've cheated. Okay, so 5 wasn't enough, but 6 would have been. Okay, I can show this on a little diagram. Here's just a probability distribution diagram that you've seen when we did chapter 6. So these are the possible number of trials from 0 up to 10 possible wins, and these are the individual probabilities of getting those wins. Okay, this is the critical region. So these combined probabilities are 0.0197. Okay, so any number of wins within here, we could have rejected the null hypothesis and said that I'd won. Okay, so it just says the critical region is a region of the probability distribution which, if the test statistic falls within, it will cause you to reject the null hypothesis. The critical value, which is this one, so the critical value is 6. That is the first value to fall inside the critical region. So when you want to work out your critical region, it's really this critical value that you're trying to work out. Okay, within here, we would reject H0. Okay, now in some questions, they will ask you to work out the critical region, and then they will give you a test statistic. So in that case, all you would then do is say whether your test statistic lies in your region or not. Right, so I hope that made a little bit of sense. I'm going to work through some standard questions now. This one is just about setting up the hypotheses, and then I'll look at a couple more of the questions. Okay, John wants to see whether a coin is unbiased or whether it is biased towards coming down heads. He tosses the coin 8 times and counts the number of times that it lands head uppermost. So X is the random variable, so that's the number of times that it's going to land head uppermost, and that can range from 0 to 8. Okay, so that is going to be our test statistic. The test statistic will be the number of heads. So he might toss the coin and get 3 heads, or he might toss the coin and get 6. However many heads he gets, that will be the test statistic. Okay, the null hypothesis. Well, John wants to see whether a coin is unbiased or whether it's biased towards coming down heads. Well, what do we assume about a coin? We assume that a coin is fair. So our null hypothesis is that the probability of getting a head is a half. But he thinks it's biased towards coming down heads. So he thinks that the probability of getting a half is more than that. So the alternative will be p is greater than a half. So when you are setting these up, you've really got to read the words carefully so that you get this right, especially this one. Okay, let's look at another one. So this is not, there's no context. This is just numbers. A random variable has a distribution B20 with some probability of success, where we're told a single observation is used to test that the null hypothesis that p is 0.15 against the alternative p is less than 0.15. Okay, so we've got x, squiggle, binomially distributed, 20 and 0.15. We are assuming that the probability is 0.15 and we need to test if the probability is less than 0.15. Okay, so to put this in a context, this might also be a game. The chances of winning might be 0.15. You might play the game 20 times. Okay, so you might play the game 20 times and someone might think that the game is not fair and actually the chance of winning is less than 0.15. Okay, we can work out our expected. That's going to be NP. So 20 times 0.15, which is 3. So the expected is 3. So we need to work out what number less than that is going to give us our critical value. 5% level of significance. So the significance level is 5%. So we need to work out our critical region. So I'm just going to illustrate with a little number line. So basically, you've got number of trials ranging from 0 to 20. You've got your expected, which is 3. Okay, so based on the fact that this is true, 0.15 is true, the expected number out of 20 trials is 3. What we need to do is test that it's less than that. For it to be less than that, it's going to be the critical region is going to be somewhere in here. Okay, so what we need to do is test some values. So ultimately what we need to work out is some value down here where the probability is less than 0.95. So remember, this is the significance level. So this is 5%. And this is the unknown, which in this case is going to represent our critical value. So that is our critical value that's going to be somewhere in here. So all we need to do is test numbers less than 3, and the biggest one that goes below 0.05 is going to be our critical value. So if I start with 2, so x is going to be 2, n is going to be 20, and p is going to be 0.15. So that is 0.405. Well, that's too big. If I try 1, that's 0.175, 0.176, which is too big. So if I try 0, then that's going to be 0.0388. Okay. This one here has now fallen below the 0.05. So it's only 0 that's gone below 0.05. So 0.0388 is less than 0.05. I'm comparing to the significance level. Therefore, the critical region is going to be that x is less than or equal to 0. Okay, it's hard to understand what's going on when there's no concepts, so you just have to trust your numbers. Okay, example 3. Again, there's no other context. A single observation is taken from a binomial distribution. Number of trial 6, probability of success will be 0.35. The observation is used to test null hypothesis, 0.35. So this is our default. This time we're testing to see if the probability of success is greater. 5% significance level, find a critical region. Okay, so X is distributed binomially. Number of trials 6, probability of success 0.35. Null hypothesis is 0.35. Alternative hypothesis, P is greater than 0.35. And the significance level is 5%. Okay, so this time, again, we're after a critical region. So we want to reject H0. We need to find a value of R that is less than the significance level. Okay, this is going to be our critical value. Okay, now remember, that your calculator will give you less than or equal to, so that's the same as 1 minus the probability that x is less than or equal to r minus 1. Okay, so write that down. This is your statement that you're comparing, that you're going to compare things to, which I've just rubbed out, which is annoying. Okay, so put some numbers in. So let's try Let's try 1. See what happens there. So x is 1. Gonna be, no, ignore me. Let's not do that. If we work out the expected, I should have done that first. 6 times 0.35 is 2.1. So because we are going greater than that, we need to test numbers bigger than 2.1. So let's not test 1, that would have been silly. Let's test 3. So we'll say x is 3, n is 6, probability is 0.35. So that's 1 minus 0.883, which is 0.117, okay, which is too big. So let's test 4. So that was r equals 3. Let's now do r equals 4. That's wrong again. That's r minus 1 equals 3. R minus 1 equals 4. So 1 minus probability that x is less than or equal to 4 is 1 minus, stick 4 in, 0.978, which is 0.022. This is less than 0.05. So 0.022 is less than 0.05. That's the one we want. R minus 1 equals 4. Therefore, R equals 5. So R equals 5, which means that the critical region is x is greater than or equal to 5. Okay, so we've done 1 minus probability of x is less than or equal to r minus 1, and by testing numbers we've found one that goes below 0.05. That was where I minus 1 is 4, which means r is 5. Okay, now it does say state the actual significance level of the test. So we've tested a 5% level of significance. 5% level of significance means that you are 95% confident that you would, if you were to reject the null hypothesis, that is true. Okay, the actual level of significance comes from here. So this 0.022, the actual level of significance is going to be 2.2%. So I'll just make a note. So the actual level of significance, spell it, is 2.2%. And this value here is the chance of wrongly rejecting the null hypothesis. So we're trying to show if we can reject the null hypothesis. So for example, if it was a game that you played 6 times and someone won 5 times or 6 times, then you would be then you would conclude really that they've cheated, if we refer it back to the original, but you will be 2.2%. There's a 2.2% chance that you're wrong. Okay, so it's all to do with this confidence. 5% significance level means that you're 95% confident. Okay, this actual significance level is the chance that you've wrongly rejected the null hypothesis. or you've wrongly sent a person to prison, depending on what the context is. So that's the actual level of significance, and yet that is just the probability that you've calculated. Okay, let's have a look at one more in a context. The standard treatment for a particular disease has a 2/5 probability of success. A certain doctor has undertaken research in this area and has produced a new drug which has been successful with 11 out of 20 patients. The doctor claims that the new drug represents an improvement on the standard treatment. Test at the 5% significance level the claim made by the doctor. Okay, so we're given loads of numbers here. A standard treatment for a particular disease has a 2/5 probability of success. So this is our P. P is going to be 2/5. A certain doctor has undertaken research in this area and has produced a new drug which has been successful with 11 out of 20 patients. So the 20 is N, and the 11 is the test statistic. And then we've got this 5% significance level. Okay, so the first thing we can write down is our binomial information. N is 20 and P is 2/5. We can then write down our null hypothesis, which is P is 2/5. Okay, now a certain doctor has undertaken research and has proved the new drug has been successful with 11 out of 20 patients. The doctor claims that the new drug represents an improvement on the standard. Okay, an improvement on the standard, which means that the doctor is claiming that this is now greater than 2/5. Okay, we could also have figured that out by working out the expected. So based on 20 and the probability of success, if you do that times that, 20 times 2/5 is 8. So based on that probability of success, you would expect 8 patients to improve, but actually the doctor's seen 11, so she thinks, or he thinks, that this is now greater. So that's where this comes from. Okay. So there's two ways. We can either work out the region, or we can use the test statistic. Okay. In this case, I'm going to work out the region. So first of all, I'm going to work out the number of patients, or the minimum number of patients, for the doctor to claim that it's been an improvement. So I want to know what value of R gives a probability of less than 0.05. Okay, I'm just going to draw my little number line again. So there's 0 patients, then there's 20. The expected number of patients is 8. So I'm looking for a value along here where the probability higher than that, so some value here where the probability higher than that is less than 0.05. So I'm going to do 1 minus the probability that x is less than or equal to r minus 1. That's my statement that I need to show. So let's try some numbers. Let's do 1 minus, I don't know, let's start with 10. So x is 10, n is 20, and p is 0.4. So when that is 10, I'm going to get 1 minus 0.872, which is 0.128, which is too big. So if I try another one, let's try 11. I'll get 1 minus 0.943, which is 0.057, which is close, but it's still too big. So I expect that 12 will do it. So if I put 12 in, I will get 1 minus 0.979, which is 0.021. Okay, so that's the one I want. This, remember, is r minus 1. So if r minus 1 equals 12, then that's going to tell me that r equals 13. So the probability that x is greater than or equal to 13 is 0.021. So therefore, the critical region has got to be x is greater than or equal to 13. So that's 13, that's our critical value, which means that in the context of the question, there would need to be 13 or more patients to have shown improvement in order for the doctor's claim to be true. Okay, now there wasn't 13, there was only 11. So what we can conclude here is that 11 is not in the critical region. Okay, if there was 13 or 14 or 15 etc. patients that had shown improvements, then they would be in the critical region, and we could have rejected the null hypothesis and said that the doctor's claim was true. 11 is not in the critical region. Therefore, we cannot reject H0. There is not enough evidence to support the doctor's claim. Okay, now that is a lot of work, a lot of maths, but that is the sort of thing that you are going to get. So often it's in a context. So I'll just show you where the marks come from. You'll get 1 for that. You'll get 1, possibly 2 for that. You'll get 1 for writing your statement. You'll get 1, possibly 2 for your calculations. Okay, and I would write a minimum of 2 here just to show that you're exploring different options. I wouldn't just stick loads, just keep typing in your calculator and just write the 1 down. Write a couple, because all that's doing is evidencing that you know what you're looking for. Then you've got 1 for a conclusion to do with the critical region. But what I didn't do, actually, which I should have done, was said that 0.021 is less than 0.05. Sort of verbalised it. But you need to write your comparison So you are clearly showing that you know your value has to go below the significance level. 1 for concluding what the critical region is, and then there'll be 2 for this. 1 for saying something about rejection of the null hypothesis, and then 1 for the doctor saying something in the context about the doctor. So 1, 2, 3, 4, 5, 6, 7, 8, 9 possible marks there. That's what you're going to get, really. Okay, so I'm hoping that you've followed that. It is a difficult concept. Have a go at those questions there.